Okay, so today we are going to be talking about the paradigm that we've been seeing with ChatGPT coming into the world about 3 years ago. And again, for the 10th time in humanity, we thought, now this new technology is going to make sure that we only have to work 3 days a week. And I don't really think that it's going to be true this time either. But we're going to see how this evolution can help us. So it's always nice to know who's standing in front of you. My name is Georges Bolsens. I work for the Belgian company Toreon as an application and product security consultant. I'm not going to read you through my whole resume. If you want to connect with me on LinkedIn, you're more than welcome to do so. I'm the only person on LinkedIn with this name as far as I know. So I know that slide deck content-wise, we are quite strapped for time, so I'm going to hand it over to my colleague Seba.
All right, thank you, George. And so my name is Sebastien as far as I know. I'm also the only one on LinkedIn, so it should not be too hard to find me. I have a background in development and security. I am the CTO, co-founder of Toreon in Belgium. We also do lots of trainings professionally, but also as a volunteer. I've been quite active in OWASP, in particular for the OWASP SAM project, Software Assurance Maturity Model. So if ever you're involved in setting up a secure development lifecycle and need a framework, this is the one you should be looking for. Also in Belgium, if you like this kind of conferences, we also organize a German OWASP Day, but then in Belgium and together with the Netherlands, and we call it the OWASP Benelux Day. So it's next week, Tuesday, completely free, paid for by the sponsors. Really nice lineup and also a second day of training. So if you still have time, it's not so far. It's in the very beautiful city of Mechelen. With that, to the topic, who of you are already familiar with threat modeling? Most of you, okay. Who of you is really successful in scaling this? Okay, all right. I think that's really the challenge that we're facing, because the software is scaling very hard, especially nowadays with AI. And so what we see with threat modeling, it's really too slow for modern development. It's a very messy, human-centric approach. We need people that are not available. We need human expertise, and in particular, security expertise, which is very scarce. It's also a very unpredictable methodology. If you put the same system in the hands of one team and another team, chances are high they're going to come up with a different threat model. So this is hard. How can we scale this? Maybe AI is going to solve this, because there is this promise of AI that's going to solve everything. You know about common artificial general intelligence? So it's the intelligence capable of performing any intellectual task a human can across a wide variety of domains. So I would assume that would also include threat modeling. And there are definitely some studies on the advancement of generative AI. I definitely want to point out a very recent one where it demonstrates that most of the current models are quite good at certain parts and certain domains, specifically like mathematics, reading, writing, knowledge. But there's a lot of other cognitive domains that are really not covered by the current models, like long-term memory, visual, reasoning, speed, and so on. So there is still definitely room for improvement. But if you know, and there's definitely an evolution. Also nowadays, we have very recently Gemini 3, we have the new Opus 4.5, so there's really, it's speeding up. So maybe we can come to what we would call like a threat modeling general intelligence. And some of you might recognize Adam Shostak in this picture. So he has written the book on threat modeling. So we just need to like integrate him and assimilate him with Gen AI, and then he will probably threat model everything for us in the far future. Question is, how far are we from that point in time? With that, we obviously will need tooling, and some of you might know some kind of threat modeling tools. We've also, as part of the research for this presentation, looked at what kind of tools are currently available to do all this stuff for us, and there are quite a lot of tools. So over the last couple of years, you see here, like the first tool was in 2001, But nowadays, we have more than 50 threat modeling tools. This is really with the scope of doing threat modeling, automating. It's not frameworks, not methodologies. These are tools. What you also see in yellow or in orange is that the integration of generative AI really speeds this up. Question is, how is this going to help us doing threat modeling? Here's a list of all the threat modeling tools. Afterwards, I'll provide you with a pointer to get access to this. But how are these tools going to help us to do better threat modeling? And for that, it's probably better to first understand the different steps, and then George is going to talk us through that.
So the show of hands that Seba asked for a little bit ago, I saw about, I think half of the hands go up, roughly, of people who know what threat modeling is. I'm going to first walk you through a very high speed, what are the stages of threat modeling and where can you automate them. For that, the DICE framework is another way of naming the 4-question framework. If that rings a bell, it's the same in a different wrapping. The first question you have to wonder when you're threat modeling a system is, what are we actually working on with this system? Diagramming or describing, doesn't really matter, the D and DICE can represent both of those words. But first you need to know what you are working on. If you have no complete view of what you're working on, it's going to be very difficult to know what can go wrong with that system. Incomplete answer to the first question is going to make you miss things by answering or in answering the second question. Something that often gets overlooked. I see a lot of hate on LinkedIn towards diagramming your systems to actually do threat modeling. I think it's still very useful because the question when we work with clients as consultants on threat modeling, you would think that the first question is a very easy one to answer. I'm going to guarantee you that 4 out of 5 threat models that I make, when we start out, we simply never get to a proper answer to the first question. Teams who develop systems rarely have a complete view of what they're building. That sounds scary, but that is the case with the majority of the organizations that I work with. A lot of knowledge does not get retained. A lot of knowledge was in the head of people that left the company. And then there you are with an incomplete answer to the question, what are you working on? Hence, you can also never properly assess what can go wrong. Assuming that you have a good view on what can go wrong, you are going to look at what are we going to do about it. Because if you stop here, then you just have a list of panic points and you're never going to sleep again. Obviously, you need some resolve to this. So then we need to figure out what are we going to do about it. And these 3 steps are usually the bread and butter of threat modeling. The last question or the last step, the evaluate step, is listed here as the last step of threat modeling, but actually you can see it as something that you can fit into those first 3 questions as well. You can evaluate whether your diagramming is good enough. You can then evaluate whether your threat elicitation is good enough, and so on. First, so when we look at diagram automation, who of you has ever heard of the tool Eraser? Show of hands, I see 1 hand up.
A couple of them, yes.
2 hands, 2 hands. Yeah. And someone in the workshop that I taught yesterday learned about it yesterday. So Eraser is basically a vibe diagramming tool. So you have a chat interface, and you can copy-paste your architecture in there. You can also link it up to a GitHub repository where it will draw wireframe diagrams of all of the different screens that are in your application. So this is becoming a bit of the future of diagramming. You just talk about what you want to see drawn, and this thing will draw the diagrams for you. It has a lot of different types of input, text input being the one that you see on the screen right now. Also mermaid syntax, if you already had diagrams as code that you can just copy-paste in there, and it will create better layouts for that, and then you can start chatting with this thing to say, no, I want this block to be on the right side of the diagram. You can just tell it. You don't have to manually move it anymore. So a lot of things are happening in the diagramming space. Eraser has been around for about a year or 2 now, and it is getting increasingly better. So depending on how you configure it, there's a lot of bells and whistles attached to it, but it's one of the leading tools when it comes to AI-native diagramming tooling. So this is an example of a complete architecture together with all of the subgraphs that it would if you would have to draw this in a diagramming tool like Draw.io or Visio, or code it together in Mermaid, it would take you a few hours. This comes together in less than a minute from an architecture description, so that goes very fast. Stride GPT, so when we move out of the diagramming realm, we go into the realm of threat elicitation. Stride GPT, who of you has ever heard about it, apart from the workshop that I gave yesterday? We have, yeah. So this is a tool that you can completely run locally as a Docker container. And you can select the model that you hook into it. So it doesn't come with a brain, so to speak. You can select the LLM that is attached to it. As you can see, a lot of the leading large language models are included, but you can also run local tools like Olama, and LM Studio, I think, is also one of those, but that got cut off of my screenshot. So if you prefer to run a local tool with a local LLM, you can do that with Stride GPT. You can also hook it up to a GitHub repository. So if you give it your GitHub API key, you can make it ingest all of your code from GitHub and then start threat modeling that. So this is something that is going to move that forward in all of the repositories that you already have in Trust. I'm going to go one slide back. So once you go into this text box and you paste your whole application architecture in here, it will generate a threat model. It will categorize it towards the Stride categories that it thinks it falls into best, because as you may or may not know, Stride is not a mutually exclusive framework. Some things can fall into 2 Stride categories, but here there's a single categorization. It can draw attack trees from that, so which order of attacks is going to lead to the apex point of ultimate compromise, and it will also suggest mitigation. It also has some risk scoring modules in there. There's a lot to explore. Also, when your architecture was lacking details, it will also tell you that it might benefit from having more detail to be more thorough in its analysis. From the same creator, we have TM Bench. So this is a bit of a benchmark of if you choose to run your LLMs locally, which locally hosted LLMs that you run on your own infrastructure, your own laptop or a server that you control, how well do those home runnable LLMs, how well do they perform when you start doing threat modeling with them? This benchmark pre-assumes that you don't have a complete 19-inch rack full of NVIDIA cards. It is doing what you can feasibly run on consumer-grade, affordable hardware. It then uses Claude 3.7 Sonnet. I think a newer model is going to come out soon to be the better LLM as a judge, which anonymously compares the output of all of these, then weights the scorings across 4 different factors, and then creates a mapping of it. This is obviously research that is ongoing, that is changing as soon as new models are coming out. This is something that will evolve over time. But it paints a clear picture where, for example, here, the top 5 is very, very, very close to each other. This is also what you see over here. The difference between number 5 and number 1 is barely 4%. So the performance there is quite good. We're also seeing a lot more integration in tools that are closer to developers. So when you look at Deepan Shah, quite a well-known name in the threat modeling community, he created a tool based on Slack. If your company is already working with Slack as a messaging platform, what you can do is you can upload diagrams into a specific Slack channel, and there is a threat modeling bot that you can talk to. So you give it everything you want to give it. You're already trusting Slack for everything else. And then it starts analyzing everything you've put into it, and then you can start having a dialogue with this robot. So this is the first level triage that you can already start doing. In a second level, security champions can follow up on that, and they can start evaluating what has been put in there. And in a last instance, you can have a number of your threat modeling experts or your cybersecurity experts review everything and then validate what has been going on. Obviously, having a human in the loop is arguably the best idea, because one of the largest problems that we have with LLMs is that they make stuff up. We call it hallucinations, which is a bit of a weird word to use in that context, but these are things that you definitely still want a human in the loop to start looking at. Was this a thing or was this not a thing? At this point in time, this robot has about the skill level of a new trainee. So you hire someone with a degree in cybersecurity who knows something about threat modeling, and they will be able to get that first rough cut here in the first level. This is something that, with this kind of tooling, can be automated to already have a first rough division of what are the 10 most important things. And divergence may happen, but I would like to argue that even though, like Seba just said, if I make a threat model and Seba makes a threat model and all of you threat modeling experts make a threat model, they're all going to look a little bit different, just like a penetration test. Every pen tester does their job in a little bit of a different way. It would be weird that the top 5 would not be very similar. The most critical issues, everyone's probably going to 5, and the more you go down that list, the more differentiation you will have. But it can already make a very good rough cut in there. If you are an Atlassian shop, you already have a lot of your knowledge in Confluence, in Jira. Lucian Corlin, a guy from the UK, he has created an agent in Rovo. So Rovo is the AI system that's embedded in the Atlassian suite. He built an agent to actually be a security architect. So now, all of the knowledge and all of the methodologies that you already have in your Atlassian suite, this agent can start performing a threat model. So your organization methodology and examples of these are previous threat models that we've made, all of this is going to be fed into there. Quick disclaimer, this is still in an alpha state. So while these initiatives exist, you do still see some oversights and some false positives in there. So do not outsource all of your thinking to here and throw out your whole security team. I would not advise you to do that. Also, how are companies implementing this kind of philosophy? So when we look at JPMC, JP Morgan Chase, they've done quite some research on how to automate this and how to build AI systems to help them with this threat modeling challenge. So they've created the AITMC, the AI Threat Modeling Copilot, which right now with Microsoft also having a product named Copilot is a bit of an unhappy choice, but they stick with it. So what they've been doing, they've been having this fine-tuned model create threat models and then have that reviewed by humans. And it's from the results we can see, so this is also a graph from this research paper. Number 7 over here was a very clear outlier, which was a hallucination. Number 1, jury was not very convinced, but all of the other ones, human reviewers agreed that what the robot output was in general, if you look at the 2 blue markers here, agreed or strongly agreed that these threat statements that came out and the threat model overall was actually a good threat model. So, of course, JP Morgan Chase, they have, how big is their security department? A few hundred people?
At least.
Yeah, so you also have to look at the scale of these things. They have a lot more people who are working on this, obviously, so they can afford to do this kind of deep research. This is a quote from Pat Opat, the CISO of JPMC. I'm going to be quiet for a second so you can read this, because this, for me, is a very powerful statement from a security leader. What for me is especially important is this last bit over here. Helping engineers understand why controls are important and not just telling people, I'm the cybersecurity expert, I'm going to come and tell you what to do, and I don't want you to argue with me, this is how it's going to be, and if you don't like it, you can That's not the way to treat people as a security professional. You're there to help people create a more secure product, and helping people understand why something is important is going to make sure that threat modeling at some point drives itself. So this is a very, very powerful outcome of this kind of research, which, as threat modeling professionals, I would actually love to be out of a job at some point, because then that means that all developers have grasped threat modeling and they are doing that. Not that I don't like threat modeling, I love doing it, but the world would be a better place if every developer inherently and every architect inherently would develop secure software. That would be great. More scientific research. So this is an example of a research paper where researchers were taking the Microsoft threat modeling tool as an input. I can already maybe hit a few holes in that research. Who of you has ever worked with a Microsoft threat modeling tool? Keep your hand up if you like the Microsoft threat modeling. There we go. Yeah, okay. So it's a free tool. It's from Microsoft. Maybe we are already predisposed to. Never mind. So the things that came out of there are threat statements. Whether they're good or bad doesn't really matter. What they then did is they fine-tuned a model and started looking at the returns that came from fine-tuning a model. This is definitely not a talk where we have the time to go really deep into the technical nitty-gritty of fine-tuning an LLM to do something. But if you want to specialize an LLM to be really specific about something, fine-tuning is really the way to go. And this is also something when you use low-rank adaptation, or LoRa, as a fine-tuning mechanism. It actually goes a lot faster than you would think. On an M1 MacBook, you can fine-tune a 7 billion parameter model with about 1,000 examples in a few hours. So this is not something that you need an NVIDIA cracking rig for to do it in a month. You can actually do that quite fast. Due to optimizations that the LoRa algorithm provides. One strange contrast that I'm seeing, and this is something that's also part of my ongoing research, is to see what were the decisions behind this research and why does it contrast with what Matt Adams was doing with TM-Bench. Because the model that was used over here, researchers said, yeah, this is, in our opinion, the best model to do it with. It was Llama 7 billion. And that is nowhere to be seen in what came out of TM-Bench. So there, I'm still wondering a few questions of how to tie that together. But that is something we're at the cutting edge of at Toreon, obviously. Then we've already been talking about artificial general intelligence. So the idea that you can just tell a robot, this is your job, go out into the world, go and do that job for me, and I am expecting good results. And if we look at, this is what we call the remote labor index. So that's research that actually measures how good are current state-of-the-art models at actually doing this. And success rates are very, very, very low. Obviously, the landscape of LLMs has changed a little bit, meanwhile, with the recent release of new Gemini and Claude models. I am not seeing the new Gemini model to all of a sudden go up to 80% success. Those models improve, but they don't improve that much. So I'm still not seeing our jobs as threat models and cybersecurity professionals being completely eradicated by AI, but there is still a long way to go. And tooling is a very important part of this. Tools can help us, but they're not going to do the complete job. So the human involvement in all of this is still really important. You also have to appreciate that this was a conversation that yesterday during drinks we were having about when you purely look at quantitative risk and you're purely looking at how to make decisions in Excel, it completely ignores the human factor of it. My company philosophy in how do I appreciate risk that makes my clients sad, but they're still paying me? Do I want to threat model against that? Or am I just about, I want to keep my clients alive so they can pay me and that's it? Like, how do you balance that as a company? And this is where I still think that human instinct needs to still be retained in all of this. Because As Nick Cave at one point said, AI can write a song, but AI does not know what it feels like to lose a child. So they can never write a song about that. They can mimic that sentiment. But it's going to be very difficult to get that sorted, which brings us to the illusion of automation, which Seva can speak better to.
Thank you. So what we've seen here is that to do threat modeling, there's a lot of advancement in tooling, but as you probably know, threat modeling is not only done with a tool. The tool will not generate the full threat model, and threat modeling is in itself also not the goal. The goal is really, together with the product team and with the involved stakeholders, to build more secure products. So, and for that to happen, we need way more than just the tool. And so automation will support us in doing threat modeling and hopefully will make us better threat modelers, but it will not solve the threat modeling scaling issue in the near future. It's also something we need to make sure that developers own as a process, as a tooling. And there we see a good advancement because the tools get closer to their tool set. It can be integrated in their GitHubs, it can be integrated in their tooling. But still, we need to be able to get their buy-in, to help them do this and to convince them to do this. And that's not something that the tool by itself will do. They will not automatically go to that Slack channel to interact with a threat model bot. And really, what I see and what we see always, it is really also a soft skill, threat modeling. It is about the human interaction, it's about the understanding of the challenges together with a group of people where the process itself of threat modeling is at least as important, if not more important, than the outcome. It's about realizing where the challenges are, how the system works, what potentially can go wrong, how we can fix it, how to come to a shared vision on security. And while tooling can support us there, in the end, most of this is human interaction, and the interaction itself is very valuable. So we really should focus on what we call human-centric threat modeling, where we leverage automation, where we leverage AI to augment what we do, but it should not, and it will probably not very soon replace our human creativity. And for becoming better threat modelers, we really need to be creative. And the future here of threat modeling is really that collaboration. So how can we become better? And I would say not only as threat modelers, but also as security and application security specialists in leveraging this kind of tooling. And there, I would say, I would recommend you, if you have a chance, to look at the recording of Daniel Miesler. He did a keynote at the OWASP US conference a couple of weeks ago on how do we leverage AI and what are the different stages of using AI in our tool set, in our way of working. And where we've come through the phases of unaided, we're not using AI. We have some chat assistant where we just do some prompting. We're now in the phase where there's agents involved and we fire up agents to do stuff for us. But it's going to go towards the next stages of how can we create intelligent workflows where we can fire up these agents, have these interactive chats with the different development teams, and build up threat models in a consistent way and share the results throughout the organization in a way that it's easy and accessible, but we still have a human control over this. And we really need to go into the mindset or the way of working, and there's an analogy here of working like a surgeon. Yes. I don't think we'll ever don't need a human threat modeler anymore, but we need to make sure that we're coming in at the moment when our expertise is the most valuable, where we have the most impact. And that's really also how a surgeon works. When a surgeon goes into an operating room, everything is prepared. The patient's already there, maybe already cut open or whatever, but he or she will do what he is really best at. And that's also what we as security specialists should try to get into, that situation where we can help a product team or a group of developers to make those final decisions, to really make sure that we have a team of people and AIs work closely together and handle that complexity and build up our expertise on threat modeling and how to become better at it. Likewise, how surgeons do it. So I don't think it will be out of a job really soon. I think it's also worthwhile to look at another analogy or some research that was recently described in a blog post by the CEO of, the former CEO of GitHub, where they looked at how developers are integrating AI in their workflows. And if there's one group of specialists, of technologists that are adopting AI very fast and that we should really look very good at how they are doing it, is developers. And developers are adopting AI very fast in their way of working, and they go through these 4 phases of being first like skeptic, is this really going to work? But then trying to experiment with it. Likewise, as threat modelers, as security specialists, we should also try to experiment with this, understand how this technology works, what it can do, what it cannot do, and explore and become better at using these different tools in these different stages of DICE. How can we become better at diagram? How can we integrate these kind of tools in the different stages? And then go to these next stages of how can we make sure that all these moving pieces work together in a way that it makes sense, and you can create these kind of workflows in a way that they support you, and they come up to you at a moment in time that your expertise is needed. And in the end, that you can oversee this as an overall orchestrator or strategist. So that's really where we're going for, or where we should be going for. So this is not really what I would call like a skill shift. It's a skill shift. It's not about eliminating threat modeling and threat modelers. It's about becoming better at this and learning and leveraging this technology. It's to not only do this, but verify what it's doing, to own the decisions, because in the end, it needs to be a human decision, and also to increase our impact, to make sure that we can do better and can do more in terms of what we are best at, and help build, in the end, more secure products. With that, I think we have some time for questions. Also, one call to action. If you want to get access or early access to this threat modeling tool directory, we have a monthly newsletter, no spam guaranteed, only on threat modeling. So if you want to register for that, you're free. You can also find it on our website, or if you trust our QR code, scan the QR code. Anything else from your end?
I think we're good to get some questions from the audience.
All right, yes.
Yeah?
Are there any questions? Please raise your hands.
Very light thing. My question.
We hear you, but the mic does not.
We'll get a little bit closer.
Okay. You run into patients or like I don't know, but you can hear me, no?
Yeah.
Wait, can we do either microphone or no microphone? Because the mix of the both is driving me completely nuts. Just without the microphone, I'll come a little bit closer. Context window overflow is definitely a thing. So this is something that you always have as a limitation. Models are getting better at it, but especially if you start running stuff locally, you're at some point going to lose context out of there. That's indeed a big limitation that consumer-grade hardware is simply not going to be doing. So you're not really running into a problem of I don't have enough parameters, because oftentimes, not oftentimes, you're going to see even a degradation in quality if you use more parameters in a model. So there's a sweet spot in model size, definitely, but context window is absolutely a thing.
Yeah. I have to say so that the evolving way of the models, that this is going to be a limit that's going to be further and further down the line. Even now with Opus 4.5, what I've heard from it, we have not tested it yet, but it really is better at managing this context window, and it's going to compress earlier input in a way that's still usable to try to come up with an answer within the limitations of the context window.
Any other questions? We still have 3 minutes.
Yes. Yes? So the question is, how do we identify a hallucination while it's not a really obvious one? By validating really what comes out of it. I think it's going to be harder and harder in a way that, obviously, what comes out of most of these technologies is, for one, very convincing. So the human in the loop and the verification is going to be important. But what we see is that also the hallucination factor is going to be less and less while we instrument and prompt better at keeping it within the guardrails of doing its job in a way that it's you make sure that it's referencing the specific artifacts that were proof for their findings. So by prompting it better, by using better LLMs, but also in the end validating the output. And that's where certainly for the next couple of months and years, a human in the loop is going to be still very important. Especially also where you're going to make a differentiation between, let's say, very high risks versus medium and low risk findings.
Two things that I also find there is that the problem of hallucinations is not a typical LLM problem. You also have human professionals who don't know what they're talking about. So that's a problem that wasn't really introduced by using LLMs. Secondly, recursive prompting helps. So writing a prompt that keeps on asking questions to clarify rather than come up with something, and fine-tuning models also really helps sharpen it down. But the risk of overfitting your model is very, very present if you don't have enough high-quality training examples. Indeed, the risk is still a human who was talking out of their neck 20 years ago, or an LLM that's talking out of its neck today. That's still the same problem, so I don't really think we're going to be solving that. So that's just a shift, in my opinion.
Okay.
Do we still have time for one more question, or will we need to?
So can I understand the questions? Are there threat modeling examples available where we can train on? Yeah. So there's definitely some initiatives. There were some older initiatives. Threat modeling cookbook within OWASP was an older one, but there is a couple of new projects. I don't remember the name here, and we should probably have involved it. But there are a couple of people that are building lists of threat models and threat modeling directories where indeed we can train our models to become better at doing threat modeling. Because, for instance, just working on the generated threat models from the Microsoft threat modeling tool is probably not good enough.
I also see that being problematic to start training on that data, because making a threat model for a medical device company or making a threat model for a bank are two completely different things. Yeah. You're talking about human safety in one aspect, and you're talking about financial loss in the other one. So if your doomsday scenarios that you're threat modeling towards are wildly different, having those two as two equivalent training inputs, I don't really see that working. So if we could come to a high volume of high-quality threat models for a specific industry, then I could see that approach working. Otherwise, it's going to be so vague that you're just running into the problem of blended whiskey. There's some really bad whiskey in there and a few good ones, and then on average, you have something that's drinkable. But that's the gist, in my opinion.
Okay, all right.
And I think we are on time.
Yes. Thank you again.
Good.
for
Thank you,
answering
OWASP Germany. You were great. Thanks.